Good morning, students. We'll start with the today's lecture. In the previous class, we have seen a few numericals on Nyquist plot, right? So we have come to an end of this chapter, right? We'll be solving few more numericals based on Nyquist plot. The steps to solve the Nyquist problem or Nyquist plot already I have told, and polar plot forms the basis for Nyquist plot, right? We'll be taking up few more numericals, and today I will be taking up the numericals in the question bank, right? Two questions I will be covering in the question bank of Nyquist plot. Okay, if any doubts are there, please unmute yourself and clear the doubts instantly so that it will be useful to all, right? Okay, we will take up this first numerical. Draw the Nyquist plot and access the stability of the closed loop system whose open loop transfer function is g of s into h of s is equal to s plus 4 divided by s plus 1 into s minus 1. Okay, we will follow the steps accordingly. We'll start with the solution. And answer I am getting it should be stable. We'll see, right? Okay, first just observe the poles, where the poles are located. Poles are at open loop poles, right? Because this is open loop transfer function, the poles are at, equate the denominator terms to 0. Poles are at s equal to s plus 1 equal to 0 means it is minus 1, s minus 1 equal to 0 means it is plus 1. Okay, two poles are there, one is located at minus 1 and another one at plus 1. So step 1, we'll start step 1. It will tell how many number of, this capital P stands for how many number of poles are lying in the right half of the S plane. Observe the poles here, minus 1 and plus 1. S equal to plus 1 means one of the pole is lying in the right half of the S plane. So P is equal to 1. This P will give us the number of poles lying in the right half of S plane. There are two poles, minus 1 and plus 1, but plus 1 is in the right half of the S plane. So P equal to 1 because number of poles in the right half of the S plane is 1. Then step 2, Nyquist stability criteria. Nyquist stability criteria. What is Nyquist stability criteria? It is n equal to minus p. So p is 1 here. So minus 1, right? P is 1 here. So minus sign as it is, and this is 1. If the system has to be stable, the Nyquist plot has to encircle once the critical point minus 1 plus j0 in which direction? Clockwise direction. Clockwise direction is negative, right? So that the system will be stable. Then step 3. Yes, we have to select the Nyquist path. Select Nyquist path. Observe any poles are zeros, any poles are lying on the imaginary axis or at origin. Yes, these poles minus 1 plus 1, no problem. This 0 is located at minus 4, right? So none of the poles are located on the imaginary axis and none of the pole is at the origin, right? So as usual, the Nyquist path will be like this. How to select the Nyquist path already I have told, right? Sigma j omega, right, plus j infinity minus j infinity, right? The Nyquist path will be passing through. This is the Nyquist path. Let me change the ink color. This is the Nyquist path. It starts from plus j infinity, it approaches 0, then it is approaching towards minus infinity, from minus j infinity to plus j infinity. This is the direction. You follow one method, this I am taking from Bakshi, this I am following. If you follow Anand Kumar, it is altogether different, right? You follow any one method. This is the one method what I am following and teaching you people, right? There are several methods to solve the problem. So this is the Nyquist path we have selected because none of the poles and zeros are lying on the origin or imaginary axis. If there any pole is there here, we have to bypass. That will be the Nyquist path, right? There is no need to bypass here, right? So this is the Nyquist path we have selected, and this is the origin, right? Okay, next. Step 4. I'll go continue here only. Step 4. Draw the polar plot of all the sections. How many sections are there? Observe here. From here plus j infinity to 0 is one section. From 0 to minus infinity is second section. And minus j infinity to plus j infinity, this is another section. Totally 3 sections are there in the Nyquist path, right? So we have to draw the polar plot for all these sections. First section, second section, third section, right? So draw the polar plot Draw the polar plot of all the sections. You strictly follow the steps so that you will understand clearly, right? Okay, in order to draw the polar plot, I need magnitude and phase, right? So this is g of s into h of s. Replace s by j omega in the given open loop transfer function. So g of j omega into h of j omega. Yes, s plus 4 is there. I will write 4 plus s. 4 plus j omega I will write. Divided by s plus 1 plus s means 1 plus j omega. Then minus 1 plus s I will write. Minus 1 plus j omega. Replace s by j omega in the given open loop transfer function, right? Okay. Okay, you can observe here. We will multiply. What are the things we are going to get? We'll see. You can observe here, this is of the form a plus b into a minus b, right? Denominator. This is a, j omega is a plus b, a minus b, right? This is a, right? This will take it as a and this as b. This as a, this as b. A plus b into a minus b, a square minus b square, right? So we will simplify it. So 4 plus j omega I will write as it is. A plus b into a minus b is a square minus b square. So a square means j omega whole square, right? Omega square I will be getting, but j square is minus 1, right? J omega whole square, j square is minus 1, so minus omega square, right? I hope you are getting. J omega whole square means j square is minus 1, so minus 1 omega square. Then a square plus b square, sorry, a square minus b square, minus b square is 1, so minus omega square. I hope you are getting, right? Okay, let me take minus outside and write it. Minus 4 plus j omega divided by 1 plus omega square. I can write it. Yes, is it fine? Minus 1 minus I have taken outside, right? Yes, let me first get the magnitude. So magnitude of this, right? I want magnitude of 4 plus j omega is under root of 4 square plus omega square. So under root of 4 square is 16 plus omega square, right? Divided by, this is already real part, just write it as it is, 1 plus omega square. I hope this is the magnitude. I hope you are getting, right? Then next we'll calculate the phase. So phase, so this minus as it is, so we'll write it here, minus. So tan inverse of omega by 4, is it fine? Tan inverse of omega by 4. One minute. Let me separate this into real part and imaginary part, and let us write it so that it will be useful. So let me write it here. Minus 4 by 1 plus omega square, and this minus I will be taking here also, minus j omega divided by 1 plus omega square. So x plus iy form, right? So tan inverse of imaginary part by real part. Imaginary part is omega divided by 1 plus omega square. Real part is minus 4 by 1 plus omega square. So minus minus it will be plus. So 1 plus omega square will get cancelled. So what I will be getting? So tan inverse of, let me write it, no problem. Minus omega divided by imaginary part 1 plus omega square divided by minus of real part 4 by 1 plus omega square. So 1 plus omega square, they will get cancelled, minus minus it will be plus. Finally I will be getting tan inverse of omega by 4. This is the phase. I hope you understood, right? Then next, for the first section, draw the polar plot of all the sections. We have magnitude and we have phase. Then we'll draw the polar plot for the first section, right? Okay. So polar plot of section 1. Section 1. So starting point of a frequency, terminating point of the frequency. Starting point of a frequency, observe here, for section 1, starting point is omega equal to plus j infinity, right? So plus j omega, omega is plus infinity. So omega is plus infinity. And terminating point, observe here, it is origin. So 0, right? So omega equal to 0. Is it fine? Then next, we'll find out, we'll substitute omega equal to plus infinity and we'll calculate the magnitude and phase. So let me write it here. Let me make a table. So here I have to write magnitude and phase, right? Let me write it here. And I will add one more column. In the previous thing I have not told, let me write it as points. What is this points? I will tell you in this numerical. In the previous problem I have not told you this. The next, rotation of plot. This you know. Only new thing is points. I will tell you what is this. Rotation of plot. Okay. Substitute omega equal to infinity and get magnitude as well as phase. Substitute omega equal to infinity here in this. So if I substitute, anything divided by infinity will be 0, right? So infinity square, right? So anything divided by infinity will be 0. Magnitude is 0. Then similarly substitute infinity here. Tan inverse of infinity is 90 degree. So tan inverse of infinity by 4, right? Tan inverse of infinity is 90 degree. Next, terminating point, omega equal to 0. Substitute omega equal to 0 and magnitude equation. So 1 plus 0, it is denominator will become 1. So root of this is 0. So root of 16 is 4. So magnitude is 4. Then calculate angle. So tan inverse of 0 is 0 degree. So whenever I get 0 degree, I should be very careful. Why, I will tell you. So okay, points I will fill up later. I will tell you, right? Then we'll fill up this points column later before drawing the Nyquist plot or polar plot, right? So rotation of plot, always you have to subtract the phase from terminating point to starting point. 0 degree minus 90 degree. So 0 degree minus 90 degree. So I am getting minus 90 degree. So 90 degree in which direction? Minus indicates clockwise direction. 90 degree clockwise. So this points column I will fill it later, right? Okay. This is very important. Whenever I get 0 degree, I should be very careful. Why, I will tell you, because okay, later on okay, let me tell you here only. You can observe here. So always what I will be taking? 0 degree minus 90 minus 180 minus 270. I will be taking like this. Whenever I get 0 degree, you can observe here. 0 degree and magnitude is 4. 0 degree magnitude is 4 means it will come here. Point will come here. But you be careful, because if any of the if the Nyquist plot points come on the right hand side, you should be very careful whether the point comes on minus 180 or what. You can observe here this 0 degree, right? Tan inverse of, okay, let me write the point later and explain you this concept. I will explain this. Okay, next I will go for section 2. I will come back to this later. I will not confuse you people. Okay. Then for section 2, no need to draw the polar plot for section 2, because section 2 is mirror image of section 1. Just write down. It is mirror image of section 1. Mirror image of section 1. Fine. Over. Section 3. This is the last section. And we will not draw the polar plot for the last section. 1 minute. Okay. We will not draw the polar plot for the last section because it represents origin in the Nyquist plot. So I will write here, it is origin. It represents origin in Nyquist plot. Over. Next, what is step 5? Determine the step 5 whether the polar plot intersects negative real axis or not. That we have to check it. So determine omega PC and intersection point. If the Nyquist plot intersects, then only we have to find out intersection point, right? So determine omega PC and intersection points. Intersection points. Sorry. Okay. So we have to rationalize g of, already you can see here, g of j omega, and it is already real part and real part and imaginary part, they are already separated. So I can take directly this. No need to rationalize once again, right? So I will be getting the same thing. So I will be taking this g of j omega into h of j omega minus 4 by, I will be taking this, right? Minus 4 by 1 plus omega square minus j into omega by 1 plus omega square. This is already real part and imaginary part are separated. This is what we want. If it is real part and imaginary part is not there, rationalize it. Already we have real part and imaginary part. So if the Nyquist plot intersects the negative real axis, then the imaginary part is 0. So equate imaginary part to 0. Equate imaginary part to 0. Imaginary part should be equated to 0, which implies, which is imaginary part here, omega by 1 plus omega square equal to 0. So 1 plus omega square it will go, so I will be getting only omega equal to 0 numerator, because omega divided by 1 plus omega square equal to 0. 1 plus omega square, if it goes that side, it will be 0. So I will get only omega equal to omega pc, that is equal to 0. But I should not get omega pc as 0. It should be always positive, finite and greater than 0, right? But here it is equal to 0. So the polar Nyquist plot will not intersect the negative real axis. That is what I am getting, right? Information. So if it is not intersecting means no need to calculate this intersection point. So stop here only, right? Then step 6. Step 6, draw the Nyquist plot. Well, before drawing, because I should be knowing the points, because these points are very much helpful. I'll tell you why. Draw the Nyquist plot. Yes, observe here. What are these points? I will tell you. I have here g of j omega and h of j omega is minus 4. This is the real part and this is imaginary part. So omega starting point omega equal to plus infinity, right? So I will substitute here. Let me get the points here. So omega equal to plus infinity, I will substitute here. If I substitute infinity here, 1 plus infinity square is once again infinity only. So anything divided by infinity is 0. So this minus sign is, so I will be getting minus 0. This sign is very important. This minus, I am calculating for starting point. Substitute omega equal to plus infinity here, right? So this minus sign as it is. Anything divided by infinity is 0. So minus 0. Next, minus j, substitute infinity here. So this is infinity, right? So anything divided by 1 plus infinity square. So anything divided by infinity is 0. So minus j 0. I hope you are getting how to get this point. Yes. This is clear. Whenever the open loop transfer function is separated into real part and imaginary part, then only you substitute and check it, right? The omega equal to 0. For terminating point, I'll check now. So I'll substitute 0 here. So 1 plus 0 square, this denominator is 1. So minus 4 I am getting. Minus j, let me check it. Minus j, what is this? Substitute 0 here. So 1 plus 0 is 1. So this is 0. So minus j 0. And these points are very important. Observe here. For this no problem, I think. Observe here, minus 0 minus j 0. So minus 0 minus j 0 will come here, minus 0 minus j 0. The point will be here, minus 0 minus j 0. And corresponding magnitude and phase, observe here, 90 degree, angle is 90 degree, magnitude is 0. So angle is 90 degree means 0 degree, this is 90 degree, right? So 0 degree, 90 degree. Is it fine? So at 90 degree, what is the magnitude? 0. At 90 degree, what is the magnitude? The point will come here only. So this both are verified. This is also fine. This is correct. Is it fine? The next, I will come to this point. So points are always correct rather than this angle, right? I will tell you why. So you take here minus, I am getting the point as minus 4 minus j 0. So I will be getting the point somewhere here, minus 4 minus j 0. I hope you are getting this. So what should be the magnitude and phase? Magnitude is should be 4 and angle should be minus 180 degree. But what I am getting here, angle is 0, right? 0 degree means it will come here. Magnitude is 4 means point will come here. So it will be wrong. So check this and then calculate the angle, right? Why it is coming like this, I will tell you. You can observe here, minus 4 minus j 0 means it will be coming on the minus 180 degree line. And you can observe here, you can calculate tan inverse of imaginary part by real part, tan inverse of 0 minus 0 by minus 4, like that, right? So you can observe here, why I'll tell you, tan of 0 degree is 0, right? Tan of 0 degree is 0. So tan inverse of 0 is 0 degree. You agree with this, right? Then next, tan of minus 180 degree. You calculate tan of minus 180 degree is also 0. So tan inverse of 0 is minus 180 degree. So tan inverse of 0 in both the cases. You can observe it. Tan inverse of 0 I get, right? Tan inverse of 0 is 0 degree, tan inverse of 0 is minus 180 degree. Minus 180 degree means this line will come. So whenever there is 0 degree, be careful, because 0 degree means the point will move towards right of S plane, right? So just observe this point where it is coming. It is coming here, minus 4 plus j0. So it is exactly up. So better you take. So I hope you are getting what I'm trying to convince you people, right? So whenever 0 degree comes, you be careful, right? So at that time you get the point. So you are getting point as minus 4 minus j. Locate this point here. Starting point minus here you are located. Okay. These 2 points we have located. Then what is the rotation of plot? It is 90 degree clockwise. 90 degree clockwise means, observe here. It will come like this. Is it fine? This is 90 degree clockwise. Is it fine? 90 degree clockwise. So this we have drawn the polar plot for this. Fine. No problem for this. Then next, this is a complete Nyquist plot will draw. This is rough, what I am telling, right? This is rough polar plot, rough Nyquist plot. Then next, section 2 is mirror image of section 1, right? So section 2 is mirror image. This is section 1 polar plot, right? It is mirror image means about the real axis. So it should be like this, I hope. And section 3 is origin in the Nyquist plot. And you can observe here, this is minus 4 minus j0. Critical point will come inside minus 1 minus j0, right? Or plus j, whatever you write, no problem, right? Minus 1 plus j0. Critical point will come inside. Okay, we'll draw the Nyquist plot now. And one more thing you can ask, since omega pc we are getting, and you sir, you told that the Nyquist plot will not intersect negative real axis, it is intersecting. So what is intersection? I will tell you before that, right? So you can observe here, when I say that it is intersecting means, you can observe here, suppose the polar plot should come like this. This is starting point and this is terminate. It will come and stop here. But I'll say when it is intersecting, this is sigma j omega. For example, the frequency is starting from omega equal to 0, it is intersecting, and this is intersection. This is starting frequency omega equal to 0 and the ending frequency omega equal to infinity. So it is starting here and it is intersecting here. But here this is starting point and this is terminating point. It terminates here only, right? So intersection means the Nyquist plot or polar plot should cross this minus 180 degree line. So omega equal to pc. So there is no intersection, I am telling. But looking at this, you people will say, sir, there is intersection. Don't get confused. That only I am telling. What is intersection? Means it should cross minus 180 degree. It is not crossing. It will come and stop here. Then it is another polar plot will start from the starting point and terminating point. So none of, whether this polar plot is also not crossing, this polar plot is also not crossing. I hope you are getting, right? So we'll draw the Nyquist plot. So draw the Nyquist plot. Step 6. Once again I will write here. Step 6. Draw the Nyquist plot. Already I know the rough Nyquist plot how I will get. Is it fine? Sigma j omega. Okay, I will make use of these points. Or else a degree also I can use. But let me write 0 degree, minus 90, minus 180 degree, minus 270 degree. Okay, minus 0 minus j starting point, right? Or else 90 degree and 0 is the magnitude. So 90 degree means this one, right? Minus 270 or 90 degree. So 90 degree line is there and magnitude is 0. This is the starting point, right? So let me write this points only. That would be better for this problem especially. Minus 0 minus j0, where omega is plus infinity. Where omega is plus infinity. Then terminating point. So minus 4 minus j0. Minus 4 it will come here. Minus 4 minus j0. Right? And rotation of plot is 90 degree clockwise. So 90 degree clockwise. So 90 degree clockwise. This is 90 degree clockwise. Then section 2 is mirror image. So here what is omega? Omega equal to 0. Then section 2 is mirror image. And critical point will come here. Minus 1 plus j0. Right? So this is the critical point. So how many times this critical point is enclosed? So take the point outside this polar plot. I will take one point outside here. Let me join that point here like this point, right? So it is intersecting here. So the direction is in this direction. So let me draw the direction. It is in which direction? Clockwise. So what is, So it is once, it is encircled only once because there is only one intersection. So in clockwise direction is negative. So just go to step 7, and write n equal to -1. You have found out. Please check whether this is matching with the step 2 Nyquist stability criteria. Yes, it is matching with step 2, n equal to -p, that is equal to -1. So n equal to -1 is matching with the stability criteria. Matching with the stability criteria means Nyquist stability criteria only. Matching with stability criteria in step 2. Because n equal to -1 here I am getting, and here n equal to -1 only. Yeah, right, in step 2 both are same. So n equal to -1 is matching with the stability criteria in step 2. Hence given system is stable. Hence given system is stable, or hence stable. I hope you are getting right. If any doubts you can ask, or else we'll go to the next numerical. Yes, or else yes, this is fine, over, problem is over. But we'll try to analyze what was the mapping theorem. This problem is over, we'll discuss some other thing. What is mapping theorem? Because Nyquist stability criteria is based on mapping theorem only, right? So n equal to z minus p, this is mapping theorem. So is there any, what is n, what we got here? It is -1. We got n equal to -1. Z we don't know. So what is p? We got, what is p? In step 1 it is 1. And calculate z here. So -1 plus 1, z is 0. What is the meaning of this? None of the zeros of the function 1 plus g of s into h of s are in the right half of the s plane. It is correct, no? Right? None of the zeros of the function 1 plus g of s into h of s are lying in the right half of the s plane. It is correct, right? I hope you have gotten this. Just with this analysis, the problem is over. Any doubts you can ask, or else I will take up the next numerical. Yes, shall I move to the next numerical? Yes. Yes. This is one more question in the question bank, right? Already one we have solved. This is one more question in the question bank. Draw the Nyquist plot and access the stability of the closed loop system whose open loop transfer function is g of s into h of s is equal to k divided by s into 2s plus 1. Right? We'll solve. The steps are same. So poles are open loop poles. Poles means open loop poles only here, because this is open loop transfer function. Poles are at s equal to 0. You could equate the denominator terms 0. S equal to 0. So 2s plus 1 equal to 0 means, what is the pole I am getting? Minus 1 by 2 is another pole. 2s plus 1 equal to 0. So s equal to minus 1 by 2. So these are the two poles. So step 1 will start. So how many number of poles are lying in the right half of the s plane? 0, minus 1 by 2. None of the poles. So it is 0. So none of the poles are lying in the right half of the s plane. This is step 1. Then come to step 2. Then Nyquist stability criteria. Nyquist stability criteria. Yes. What is Nyquist stability criteria? N equal to minus p. What is p? It is 0. So n equal to 0. For the system to be stable, the Nyquist plot should not encircle the critical point -1 plus j0. It should not encircle. Let us see whether it will encircle or not. Then we'll move to the step 3. Select the Nyquist path. The steps are same. Select the Nyquist path. Yes, you can observe here that there is one pole lying at the origin, s equal to 0, right? So we have to bypass this pole lying at the origin. So we have to choose the Nyquist path in such a way that it has to bypass this pole situated at s equal to 0. So we will choose the Nyquist path. Sigma j omega. So one of the pole is located here at s equal to 0. I am not worried about other poles. The poles which are lying on imaginary axis and the poles which are lying at origin, I am worried about only those poles. So s equal to 0, once the pole is situated here, right? So we have to bypass this. So let me select the Nyquist path. I'll change the ink color. This is plus j infinity and this is minus j infinity. So the Nyquist path starts here and it moves towards the 0. It has to bypass. It will bypass. Then it will approach to minus infinity. Then it will cover entire right half of S plane. This will cover entire right half of S plane, right? So it will start. Let me show the direction. Right. So how many sections are there? We'll try to identify. So section 1 from plus j infinity to plus j0. Let me take this just above this 0. Let me call it as plus j0. Below we will call it as minus j0. This one, right? This is plus j0. This is minus j0, right? Section 1 plus j infinity to plus j0 is section 1. Plus j0 to minus j0 is section 2. Then minus j0 to minus j infinity is section 3. Minus j infinity to plus j infinity is section 4. Right? Observe what is the radius. We will write. So I will take some other color. So if I take the radius, this is infinite. Right? This radius r tends towards infinity because it has to cover entire right of S plane now. And if I take this smaller one, another one, let me take some other color, purple. So this radius, it is r tending towards 0. R tending towards 0. This radius of semicircle is almost 0. And radius of this big circle semicircle is infinity, right? Okay. Next, step 4. I'll start here only. Step 4. Yes, I have 4 sections. Section 1, section 2, section 3, section 4. Draw the polar plot of all the sections. Draw the polar plot of all sections. Okay, in order to draw the polar plot of all the sections, I should know the magnitude and phase. So first replace S by j omega and get the transfer function in terms of j omega. J of j omega and h of j omega is equal to k divided by S is j omega. Then 1 plus 2s I will write. 1 plus 2s. 1 plus 2s. 2s means j omega. 2s is j omega. Right? Just I have rewritten. Next, get the magnitude. Get the magnitude. So magnitude is magnitude of k is k only. K plus j0 under root of k square plus 0 square. It is k only. The next 0 plus j omega under root of 0 square plus omega square. So it is omega only I will get, right? You are getting and 0 plus j omega under root of 0 square plus omega square. So omega I will get from this. Then calculate magnitude of this. Under root of 1 square is 1. Then 2 omega whole square. 2 to the 4 omega square. I hope you are getting right. Under root of x square plus y square. X plus jy under root of x square plus y square. So this is the magnitude. Then calculate the phase. So for k, tan inverse of k plus j0 if I write tan inverse of 0 by k, it is 0 degree. For j omega, it is lying on j omega 0, right? It is 90 degree, right? Tan inverse of 0 plus j omega, tan inverse of omega by 0, tan inverse of infinity is 90 degree, right? Or else based on location also directly you can write 90 degree. Then tan inverse of imaginary part by real part, tan inverse of 2 omega by 1. Tan inverse of 2 omega divided by 1 I will not write. Then if I take it to numerator, what I will be getting? Minus 90 degree minus tan inverse of 2 omega. This is the phase what I am going to get. Is it fine? Next, we will take up the section 1. This one, section 1. Let me go to the next slide. Or okay, let me go to the next slide. Section 1 I will be taking. Section 1. So starting point, terminating point. Let me make a table so that it will be clear. So what is starting point? Plus j infinity to plus j0. Oh, so omega equal to plus infinity. So omega equal to plus infinity is the starting point. And what is the terminating point? Omega equal to plus 0. J omega, right? Plus 0. plus 0. Okay, fine. Then next we should calculate the magnitude and phase by using the magnitude and phase equations. We will calculate it. So we'll calculate later. Then points. These points here it is not necessary, but let me write it, no problem, so that you'll get an idea. Points we'll calculate later. Then last is rotation of plot. Rotation of plot. Yes. Okay, starting point. Omega is plus infinity. Substitute in magnitude equation and phase equation and calculate. Omega equal to plus infinity. So substitute anything divided by infinity is 0. So magnitude is 0. Then calculate the phase. Tan inverse of infinity is 90 degree. Minus 90, minus 90. Right? Tan inverse of infinity. This one is minus 90 degree. Minus 90 degree, minus 90 degree, minus 180. Over. Then for terminating point, TP. So omega is plus 0. So substitute omega equal to plus 0 in magnitude equation. Anything divided by 0 is infinity, right? So if I substitute omega equal to 0, anything divided by 0 is infinity. So magnitude is infinite. So we will calculate the phase. Substitute omega equal to 0 in phase equation. So tan inverse of 0 is 0. This will vanish. So I am getting minus 90 degree. So we'll take up these points later. So we will find out the rotation of plot. Minus 90 degree. Minus of open bracket minus 180 degree. So what I will be getting? Plus 180. 180 minus 90 means plus 90 degree I am getting. Is it fine? So it is 90 degree. Which direction? 90 degree clockwise or anti-clockwise? Clockwise is negative, anti-clockwise is positive. So 90 degree anti-clockwise. I am getting plus means anti-clockwise, right? If it is negative means clockwise. Okay, points we will concentrate later. Next, come to section 2. So starting point, terminating point. So we'll make a table. So don't keep quiet. If any doubts, please ask. And the terminating point of section will be the starting point of this section 2. So it is plus 0, right? This will be same. You can observe here, right? Sorry, 1 minute. Yes, here it is. So was minus 0. Sorry, let me write it as minus 0, right? Minus 0. Because starting point is plus j0. Sorry, it is plus 0 only. Oh, I am making mistake. Because plus j0 to minus j0. This is section 2, right? So minus j0 means minus 0. Is it fine? Then we will calculate magnitude and phase here. I think points are not required here, but let the column be. If it is required, I will write it, or else we can skip this. But in the previous problem, it was essential, so I have taken, right? So next, rotation of plot. Okay, and since the terminating point of section 1 is starting point, so no need to calculate magnitude, directly you write whatever you are getting. Magnitude is infinity and angle is minus 90 degree. And one more thing, at omega equal to minus 0, the magnitude remains the same. I'll tell you why. Magnitude remains the same. No need to substitute in magnitude and phase equation and calculate. But angle will be reversed. If it is minus 90 here, it will be plus 90. If it is 180 degree here, minus 180, it will be plus 180. So observe here, just I'll show you here. From here to here, if I take magnitude means whether it is plus or minus, magnitude remains the same. It is infinity. But angle here, it is minus 90 means it will be plus 90 here. If it is minus 180 degree means it will be plus 180 degree. Exactly opposite. So no need to substitute in these two equations and calculate, right? For section 2, no, don't calculate. So terminating point will be the starting point. So write down magnitude and phase. For omega equal to minus 0, so magnitude remains the same, but phase will be exactly opposite. So calculate the rotation of the plot. Plus 90 degree minus of minus 90 degree. So it is plus 90 minus plus 90 plus 90. So it is 180 degree. Plus 180 degree I am getting. So what is the rotation of the plot? 180 degree clockwise or anti-clockwise? Positive means it is 180 degree anti-clockwise. If I get minus 180 degree, it will be 180 degree clockwise, right? You know the signs. Then points, let me see if it is required or not. Then go to the section 3, but section 3 is mirror image of section 1. So no need to draw the polar plot for section 3. Write down just one sentence. Section 3, just you write down, it is mirror image of section 1. Mirror image of section 1. Next, section 4. Section 4 is the last section. You can observe here, section 4 is the last section. For last section, we will not draw the polar plot. It represents origin in the Nyquist plot. Just write down that. It represents origin in Nyquist plot. Yes, we have covered all the sections. Next, we'll go to the next step, step 5. Step 5. Whether the polar Nyquist plot will intersect negative real axis or not. So if it intersects, then we have to determine omega PC and the intersection point. So let us write determine omega PC and intersection point if it is applicable. If I get omega PC 0, don't worry, right? So determine omega PC and intersection points. Intersection point, not points, intersection point. So first we'll take g of j omega and we will try to rationalize it. If it is already real part and imaginary part, it is fine. In the previous problem, it was already the transfer function is separated into real part and imaginary part. Let me check here. So it is not separated. We have to rationalize it. So let me take j of j omega to h of j omega. That is equal to k divided by j omega. K divided by j omega into 1 plus 2 j omega. So we have to rationalize this. So why we are rationalizing? Because in order to separate into real parts and imaginary part. In the previous problem, it was already separated into real part and imaginary part without rationalization, right? So just here I can write this j omega as 0 plus j omega, means the rationalization means minus j omega it will be taking, right? Then 1 plus 2 j omega means 1 minus 2 j omega divided by. So this factors should be cancelled. So I'll take the same thing in the denominator also, 1 minus 2 j omega. So we will rationalize it, we'll multiply and see all the things. So let me change the ink color. I am doing the rough work here. Let me do the rough work here. I'll write rough. So first I will multiply minus j omega into 1 minus 2 j omega. So what I will be getting k, I will write as it is, k as it is, this one. So minus j omega into 1, minus j omega I will get. Then minus into minus plus, but j into j is j square. J square is minus 1. So minus into minus plus, but plus into minus, once again minus I will get, because j square is minus 1. I hope you are getting. Minus into minus, it will be plus, but j into j is j square, it is minus 1. So I am writing minus here. So j is over. So 2 omega into omega. So 2 omega square. If I am making mistakes, please tell me. Omega into omega, omega square, 2 as it is. Is it fine? It's correct. So numerator, this is the numerator what I am getting. So let me separate real part and write it. Numerator nr. Numerator is equal to let me multiply k. First I will write the real part minus 2k omega square. This k I have multiplied with the second term. Next I will multiply minus j omega k. So this is numerator. Let me do the denominator, right? So we'll do the calculation of denominator. 1 plus 2 j omega into 1 minus 2 j omega. A plus b into a minus b. A square minus b square. So a square, I am multiplying only these two first. This and this. Later on I will see this. We will see this later on, right? So this double tick we will see later. So 1 plus 2 j omega into 1 minus 2 j omega. A plus b into a minus b. A square minus b square. A square is 1 minus b square means 2j omega whole square. 2j omega whole square. A square minus b square, right? So 1. So j square is minus 1. So 1 plus it will become. J square is minus, so 1 plus 2 square is 4 and omega square is omega square. So from these two I got 1 plus 4 omega square. Then you multiply this j omega into minus j omega. So what I will be getting? J omega into minus j omega. So Plus into minus is minus, but j square, j into j, j square, so it will become plus omega square I will be getting. So these two, so just multiply omega square into denominator, what I will be getting, denominator is omega square into 1 plus 4 omega square. This is denominator. So let me write in the next slide. Let me go to the next slide and change the ink color. G of j omega into h of j omega. So numerator, what I am getting, numerator minus 2k omega square, minus 2k omega square minus j omega k divided by denominator omega square into 1 plus 4 omega square. Omega square into 1 plus 4. We will separate into real part and imaginary part. Minus 2k omega square divided by this omega square into 1 plus 4 omega square minus j omega k divided by omega square, denominator same, omega square into 1 plus 4 omega square. So real part, this is real part and this is imaginary part. If the polar plot intersects the imaginary axis, let us assume it is intersecting imaginary axis, if it is intersecting the negative real axis, then imaginary part should be 0. So we will equate imaginary part to 0, equate imaginary part to 0, equate imaginary part should be equal to 0, right? We will do that. So what is imaginary part? Minus this here, minus this j, you leave it, minus omega k divided by omega square into 1 plus 4 omega square. So if I equate this term to 0, this denominator omega square into 1 plus, it will go that side and it will be 0. So what I will be getting, omega k equal to 0, omega k equal to 0, which implies omega equal to omega pc and it equal to 0. But what I should get, omega pc, it should be positive, finite and greater than 0. Whether this is satisfying? No. So there is no intersection point, right? There is no intersection point. Please keep in the mind. There is no intersection of this Nyquist plot with the negative real axis. So no need to calculate that intersection point. If I am getting some omega pc value, I have to, suppose I am getting 2 here, I have to substitute this in real part and calculate that intersection point q, right? That we have done in the previous problems. Okay, next, step 6. Okay, step 6. Draw the Nyquist plot. Draw the Nyquist plot. Yes, draw the Nyquist plot. But these points I told no. Here it is not required, but let me write the points so that you will understand it thoroughly. You can compare, right? So let me calculate these points also. I have real part and imaginary part here, right? So g of j omega and h of j omega with this open loop transfer function, now it is in frequency domain and it has been separated into real part and imaginary part. I want the points. So what is the starting point here? Let me take section 1. Starting point is omega equal to plus infinity. Substitute here. So anything divided, so let me, okay, omega square will get cancelled. Here if I substitute plus infinity, anything divided by infinity is 0, but sign is minus. Anything divided by infinity is 0, so minus 0 here. So let me write it here, minus 0. I hope you agree with me. Then calculate the imaginary part, omega plus infinity, substitute plus infinity in imaginary part. So anything divided by infinity is 0, minus j 0, minus j as it is, but anything divided by infinity is 0, so minus j 0. So like these signs are very important. Don't, if it is plus minus, you will go wrong. So you should be very careful in calculating the points. Here in this problem, points are not required. Whenever 0 degree comes, at that time you should be very careful. I am getting minus 90, minus 180, no problem here. No need to calculate the points. But why I am telling you the points means just to make you understand. Later on, with respect to points as well as magnitude and phase, I will try to make you understand. Here no need to calculate, you can leave it. Okay, next, omega equal to 0 is substitute. Section 1, terminating point, omega equal to 0. Okay, substitute omega equal to 0. So this omega square will get cancelled. This is 1. So what I will be getting, minus 2k. Observe here. This, because I am substituting, this 0 means this will be 1 plus 0, 1. Omega square will get cancelled. So minus 2k. I will get minus 2k. Let me substitute omega equal to 0 in imaginary part. So this will see here, observe here, this omega anything divided by 0 is infinity, minus j infinity. How it is minus j infinity you came to know? Because substitute omega equal to 0 here. Omega square, omega will cancel. Anything divided by 0, this omega is 0, right? Omega square, this omega will cancel with this square. So I am getting omega here. Anything divided by 0 is infinity, right? Minus j infinity. I have written here, right? Similarly, you calculate for section 2. Observe, right? So it will be same only, minus 2k. But observe here, but we will calculate. No need to calculate because anyhow it is omega plus minus 2k, same only, minus j infinity, because it is plus 0 only. For minus 0 we will calculate. Observe here, omega is minus 0. Please be careful, omega is minus 0. So omega square will get cancelled. Omega is minus 0. 1 minus 0 is 1 only. Minus 2k only I am getting. Minus 2k. And omega is minus 0. Substitute in imaginary part. Minus 0. So omega will get cancelled. This square will get cancelled. But omega is minus 0, right? This will be 0. This will be 1. So minus 0 means minus into minus plus. So plus j infinity. Anything divided by 0 is plus j infinity we will get. I hope you are getting right these points. Okay, I will tell you the significance of these points. But we'll draw the polar plot first. Sorry, Nyquist plot first. So we'll draw the Nyquist plot. Zero degree, minus 90 degree, minus 180 degree, minus 270 degree. Okay, we'll change the ink color. For section 1, we'll take up the section 1. Minus 180 degree, magnitude is 0. Minus 180 degree, magnitude is 0. Minus 180 degree line is this, magnitude is 0. Here, I will mark the point. Then next, terminating point, minus 90 degree, infinity. Minus 90 degree, infinity. Observe here, minus 90 degree is here. Infinity I can mark it here. But some people will say, why you take infinity here? It cannot meet. So some people will take here. It is true also. It is true also. So let me take the point here. I can take here also, no problem. You can go ahead. You can take the point here and draw the Nyquist plot, no problem. But if you look at the point, observe here. Why? So I am telling you, if you look at the point here, for terminating point, minus 2k minus j infinity. So minus 2k means somewhere it will come here, minus j infinity means somewhere it will come here, right? Minus 2k minus j infinity. I hope you are getting. So this is the significance of those points. Minus 2k minus j infinity. The point will come here, right? So let me mark the point here. 1 minute. 1 minute. Just I'll come. Okay, sorry. I thought your CR has called because I got a call. Let me put it in vibrating mode. Okay, fine. 1 minute. Okay. We'll proceed with our lecture. I hope you are getting. So the point will come here, right? Minus 90 degree, infinity, right? Minus 90 degree is this line. Infinity means I will not take here, right? Because infinity, so will be, some people will take infinity. But if I look at the point, minus 2k minus j infinity. Minus 2k means it will come on negative real axis, minus 2k minus j infinity. So point will come here. So what is the rotation of plot? Observe here, 90 degree anti-clockwise direction. So 90 degree anti-clockwise. We will draw it 90 degree anti-clockwise. Okay, if point lies here, I could have drawn like this. So it will be clear to you, 90 degree anti-clockwise. So this one, I'll draw it here like this. So this is anti-clockwise or clockwise? Anti-clockwise means this one, right? Anti-clockwise, right? So direction is like this. So section 1 polar plot is over. Next, come to section 2. So let me change the ink color. Let me take another ink color, this one, right? And you don't change the ink, just for your reference I am changing the ink color. Let me come to section 2. So it is minus 90 degree minus infinity, means the same here, it is stopped here. Next we'll take plus 90 degree infinity, plus 90 degree infinity. Plus 90 degree means here this one, plus 90 will come here, 0 degree plus 90 degree. Infinity means it has to come on this line, it has to come on this line, but will not take on this line. Just observe the point here, minus 2k plus j infinity, minus 2k plus j infinity. So corresponding to this I'll be taking this. Is it fine? I hope you are getting. So starting point is here, terminating point is here for section 2. What is the rotation of the plot? It is 180 degree anti-clockwise direction. So we have to draw from here to here, it is 90, 90, 180, right? So we have to draw the big circle. -90 degree and another 90 degree. 90, 90. Is it fine? So this is for section 2. Because 180 degrees here. From here to here it is 90 degree, another 90 degree, 180. Is it fine? I am telling, if point comes here also no problem. Instead of here, if it comes here also, it will be like this. That's all, right? If it point comes, right? Okay, fine. Next, section 3. Section 2 is over. Next, section 3 is mirror image of section 1. Section 3 is mirror image. Let me change the ink color. So this is section 1. Its mirror image means it has to be like this. So this is like this means this is like this. This is mirror, but arrow mark you observe here. And section 4 is the origin in the Nyquist plot. That's all. Is that fine? So I hope this is the Nyquist plot. Yes. Then critical point is here because it is not intersecting, right? So it is outside this. -1 plus j0 is the critical point. Is it fine? So let us go to the step 7. So what is n? Here the Nyquist plot is not enclosing this critical point. So n is equal to 0. No encirclements because Nyquist plot is not enclosing critical point. Whether this n equal to 0 matches with the stability criteria in step 2, check it. In step 2 n equal to 0, yes, it is matching. In step 2 n equal to 0, right, it is matching. So n equal to 0, this is matching with, you can write this is matching with Nyquist stability criteria in step 2. In step 2 also I am getting n equal to 0. Here also I am getting n equal to 0 because it is not encircling this critical point. So in step 2 also it is n equal to 0 only. So given system is stable. I hope it's clear, right? So 2 numericals are over of question bank. If any doubts are there, you can ask, right? I hope you understood the significance of these points, right? Either I can represent the starting point by using magnitude and angle condition or these points. Is it fine? Next, the last numerical we will solve because next class is not there. So I will be taking one more, or else it is over only, I can leave it, but one more problem is there. Let me take that problem and I will leave you. Only one more problem with respect to Nyquist plot. I hope there is no doubt with respect to this, right? I'll proceed. If any doubts, you can unmute yourself and talk to me. This is stable, answer is stable, yes, that is correct. Next, we'll take up another numerical. Yes, this one. This is not there in the question bank, but still anyhow it has to be done, right? You should be knowing what is Nyquist plot, all those things, a variety of problems I am solving, right? Solution. For a certain control system, g of s into h of s is equal to k divided by s into s plus 2 into s plus 10. Sketch the Nyquist plot. Yes, we know how to sketch, we'll sketch it. And hence calculate the range of values of k for stability. Yes, here the answer is given. The range of values of k lies between 0 to 240. If the value of k lies between 0 to 240, then the system will be stable. They are telling, right? So we have to find these range of values of k. How to find out, I'll tell you. You know how to draw the Nyquist plot. The procedure is same. We'll do the same thing, right? So the poles are okay. Just one of you respond. Other people are there in the class. Yes or no? You respond. You people are there in the classroom?
Yes, sir.
Yes, sir.
Okay, fine. Okay, I got the confidence, so I will continue. Okay, fine. Poles are okay. Poles are located. Poles means open loop poles because this is open loop transfer function. Poles are located at s equal to equate the denominator term to 0. So s equal to 0 one pole. S plus 2 equal to 0 means minus 2. S plus 10 equal to 0 means minus 10. So step 1, it's the same steps. If you follow these steps thoroughly, then you will do the Nyquist plot very easily. No, there is no confusion at all. So calculate how many number of poles are lying in the right of 0, minus 2, minus 10. None of the poles are lying in the right of the S-plane, so P is 0. Because none of the open loop poles are lying in the right of the S-plane, right? So P is 0. Step 2, Nyquist stability criteria. Nyquist stability criteria. So what is Nyquist stability? N equal to minus P. So what is P here? It is 0. So N equal to 0. For system to be stable, n number of encirclements should be 0. Means the Nyquist plot should not encircle the critical point minus 1 plus j0. That is the stability condition, right? We will make use of this stability condition in order to determine the range of k, right? In order to we'll see how. Then step 3, select the Nyquist path. Select the Nyquist path. Okay, we will select the Nyquist path. Okay, this is S-plane. Why I am telling S-plane means whatever the Nyquist plot I am getting, that is F-plane. S-plane to F-plane mapping, I told no. This is S-plane, Nyquist path. And finally Nyquist plot I get, that is in F-plane. Right? S-plane to F-plane mapping in the theory I told, right? So in order to highlight that point, I am stressing here. That's all. Next we'll change the ink color. Check any of the poles are lying at the origin or imaginary axis. Yes, one of the pole is there. This is lying at the origin. So this one, right? So you have to bypass this minus 2, we are not worried about these two. We are worried about the poles and zeros lying on imaginary axis and pole at origin, right? So here plus j infinity. Okay, 1 minute. It's not permitting me to write here. Okay, let me take it here. Actually it should not be, let it minus j infinity. It should be equidistance. So if I write it here, point should come here, let it be, no problem. So it will start here. Nyquist plot, it has to bypass at the origin, this origin, right? It will come to plus j infinity and it will cover entire right of S-plane. It will cover entire right of S-plane. So this is the arrow mark. You should show the arrow mark clearly. So how many sections are there? We will see. So I'll change the ink color. This is section 1. This is section 2. This is section 3. And this is section 4. And here 0 means above point I will take it as plus j0. And below point I will take it as minus j0. This one, right? Okay, this is the Nyquist path we have selected. Then we'll proceed with step 4. And one more thing, this one, the radius of this big circle, semicircle is infinite. Radius tends towards infinity. And the radius of this smaller semicircle, let me change the ink color. Radius of this smaller semicircle r tends towards 0. Its radius is 0, its radius is infinity, right? Okay. Then step 4. I have 4 sections, section 1, section 2, section 3, section 4. Draw the polar plot of all the sections. Draw the polar plot of all sections. Okay, we will draw. Before drawing polar plot, I need magnitude and phase. So let me convert this from S plane to frequency domain, j omega. Replace S by j omega. K divided by S means j omega. S plus 2, I will write it as 2 plus S. 2 plus S means 2 plus j omega. 10 plus S I will write. S 10 plus S means 10 plus j omega. Okay, next we will calculate the magnitude. So magnitude of k is k only in the numerator. So for this magnitude 0 square plus under root of 0 square plus omega square means omega I will get the magnitude. From this under root of 2 square is 4 and omega square. 4 square 2 square is 4, 4 plus omega square. Next under root of 10 square is 100 plus omega square. This is the magnitude. Then calculate the phase. Angle of k plus j is 0, right? Tan inverse of 0 by k. It is 0 degree numerator. For j omega, I will be getting angle as 90 degree based on the location of the point. Then for this tan inverse of imaginary part by real part, tan inverse of omega by 2. Next, tan inverse of imaginary part by real part, omega by 10. Tan inverse of omega by 10. So we'll write down the angles. Take it to numerator, minus 90 degree minus tan inverse of omega by 2. Let me write it here. Okay, I have space. Tan inverse of omega by 10. Okay, this is the phase equation. Let us go to section 1. Section 1. Section 1. So starting point, terminating point. So omega equal to what we'll see. Then here I'll be writing magnitude and phase. These points, let me skip it here in this problem, not required. If it required, I will take it. It is not mandatory to write this column. If you want, I will take it, or else I will skip it. Then next, rotation of plot. Rotation of plot. Okay, for section 1, starting plus j infinity I should write. It is not j0, plus j infinity. So plus infinity to plus 0, plus j infinity plus j0. So omega is plus infinity to plus 0, plus infinity to plus 0. This is starting point, this is terminating point. Starting point plus infinity, terminating point is plus 0, right? So calculate magnitude, substitute omega equal to plus infinity in magnitude equation. Anything divided by infinity is 0. So this is 0. Calculate the phase. So tan inverse of infinity is 90 degree. Tan inverse of, so minus 90, minus 90, minus 90. So minus 270. 9 to 18, 9 to 18, minus 270 degree. I hope you are getting. Then for terminating point, substitute omega equal to 0 in magnitude and phase equation and calculate magnitude and phase. Omega equal to 0. Anything divided by 0 is infinity. Then angle. So tan inverse of 0 is 0, 0. These two will vanish. So minus 90 degree. Then we'll see the rotation of the plot. These points we will see. It is required or not, we'll see. Minus 90 degree. Minus of minus 270. So how much I will be getting? Plus 270. 270 minus 90. 180. Plus 180 degree. So 180 degree clockwise or anti-clockwise? It is positive means anti-clockwise. Clockwise is taken negative, right? So it is anti-clockwise. These points we will see. Question mark. We don't know right now. We will leave it. If it is not required, we will leave it. We will not fill this. Then we will go to section 2. Then what is starting point? What is terminating point? So here we will write starting point, terminating point. Then we will calculate magnitude and phase. The 2 points if required. It is not mandatory. Points will give us idea, exact idea, right? Then rotation of plot. Okay, the starting point and the terminating point. Plus j0 is the starting point, minus j0 is the terminating, means plus 0 to minus 0. So plus 0 to minus 0. For plus 0, the terminating point of section will be the starting point of section 2. So we will no need to calculate. Directly write infinity and minus 90 degree. Then here for omega to minus 0, don't calculate. Directly you can write. Magnitude remains the same. but angle will be opposite. If it is minus 90 means it will be plus 90 here, because they are symmetrical in nature, plus j0 and minus j0, but magnitude remains same, angle will be opposite, phase will change. Okay, we will see this later. Put question mark. Rotation of plot will find out. Plus 90 degree minus of minus 90 degree, plus 90 degree minus of, so minus into minus, plus 90 plus 90, 180 degree. So 180 degree anti-clockwise direction. Then come to section 3. You can observe here in the Nyquist path, section 3 is mirror image of section 1. Just write down that. Mirror image of section 1. No need to calculate. Mirror image of section 1. Then section 4 is the last section. No need to draw the polar plot. It represents origin in the Nyquist plot. It represents origin. Origin in Nyquist plot. Because section 4 is the last section, right? And it represents origin in Nyquist plot. Then step 4 is over. Next step 5. Step 5. If the Nyquist plot intersects the negative real axis, then we have to determine omega pc. Determine omega pc, the phase crossover frequency, and the intersection point. Intersection point. G of j omega and h of j omega, whether it is separated into real part or imaginary part, or else you rationalize it. So g of j omega and h of j omega, it is there, we have to rationalize. So we'll take this k divided by, I hope it is better to go for next slide, I think. Let me do it, no problem here. K divided by j omega into 2 plus j omega 10 plus j omega. This is the open loop transfer function in frequency. Rationalize it. So 0 plus j omega means 0 minus j omega. I will not write 0, just minus j omega. 2 plus j omega means 2 minus j omega. Here 10 plus j omega means 10 minus j omega. Two minus j omega into 10 minus j omega. Take the same thing so that it will cancel and we will get back the same thing. So now I will do with some other in color, numerator and denominator separately. So first what I will do, I will multiply these two things. Then I will multiply with minus j omega, then I will take k. First I will concentrate on only numerator. Let me start here, rough work. This is rough work, only numerator part. So 2 minus j omega into 10 minus j omega, I am doing these two first. These two first. So 2 10 are 20. Next 2 into minus j omega, minus 2 j omega. Next minus j omega into 10, minus 10 j omega. Then next minus j omega into minus j omega. Minus into minus plus, but j square is minus, right? So minus into minus plus, j square minus omega square I will get. Omega into omega minus omega square. I hope you are getting. Minus j omega into minus j omega, right? So minus into minus is plus, but j into j is j square. It is minus 1. So 1 minute. Minus into minus plus. Yes, I am written minus. It's correct. And omega into omega is omega square. This is fine. Next, these two terms are multiplied. Let me write it into, so 20 real part minus omega square. I'll take it first. This is real part, 20 minus omega square. Imaginary part minus 10 j omega minus means minus 12 j omega. 10 plus 2, 12 j omega. Okay, next I will multiply with minus j omega into k. Minus j omega k. K is there, right? Minus j omega k I will multiply. Minus j omega k. Minus j omega into k. Multiply with this. So let me write it. Minus 20 j omega k. I hope it is correct. Minus to plus, right? Minus 20 j omega. Minus into minus plus omega into omega. Omega cube it will become j omega cube k. I hope it is correct. So minus into minus it is plus j omega k into omega square. J omega cube k. Is it fine? Minus into minus plus. But observe here, j into j is j square, it is minus 1. So minus into minus plus, but it will become minus because j square is minus 1. So j is vanished. So what I will be getting? Omega k into, so 12 omega. So 12 as it is. Omega into omega is omega square k. So this is numerator, entire numerator. But let me separate into real part and imaginary part. So minus 12 omega square k. This is real part. Minus 12 omega square k is real part, and imaginary part, let me check it, right? So can I take j omega as common, plus j omega? Let me take plus j omega. Is it fine? Plus j omega k I will take. J omega k. Is it fine? If I take j omega k, what I will be getting? Omega square for this one, because j omega cube k I will be getting this, minus j omega k is taken minus 20. I hope it is correct. Is it fine? This is numerator, entire numerator. This is numerator is over. Next we have to calculate in the same way we have to calculate denominator. This is rough work what I am doing. Rough work means it should be correct. It is not rough. It is required in future next steps. It should be correct. So next first we will multiply this j omega into minus j omega. So what I will be getting? J omega into minus j omega. So plus into minus minus, but it will be plus only because j square is minus 1, right? So omega square I will get. Next I will multiply 2 plus j omega into 2 minus j omega. A plus b into a minus b. A square minus b square. What I will be getting? A square is 4 minus b square, j omega whole square. A plus b into a minus b. A square minus b square. A square minus b square, right? So 4. J square is minus 1. So it will be plus. Minus to minus plus. So omega square. Next I will multiply this with this. So a plus b into a minus b. A square minus b square. A square is 10 square. That is 100. Minus b square. J omega whole square. So 100 plus omega square I will get. So denominator what I will be getting? Overall denominator, multiply this. So denominator will be, denominator equals omega square into 4 plus omega square into 100 plus omega square. Okay, next we'll go to the next slide and we'll write down that. So g of j omega into h of j omega. What is numerator? Minus 12 omega square k plus j omega k into omega square minus 20 divided by denominator. Omega square into 4 plus omega square. 4 plus omega square into 100 plus omega square. I hope it is correct, right? I have not made any mistake. So let me separate into real part and imaginary part and write it here. So minus 12 omega square k divided by this denominator, entire thing. Omega square into 4 plus omega square into 100 plus omega square plus j omega k into omega square minus 20 divided by this denominator, same as it is. Okay, this is real part and this is imaginary part. If the Nyquist plot intersects the negative real axis, then imaginary part is 0. So equate imaginary part to 0. Equate imaginary part to 0, equal to 0. Let me take imaginary part, this one. So omega k into omega square minus 20 divided by omega square, this equal to 0. But equal to 0 means this denominator will go that side and it will become, so I will be taking only numerator. So which implies omega k into omega square minus 20 equal to 0. I hope you are getting, because if I take divided by this denominator, it will go that side and it will become 0. So I will not write this denominator. Here which implies omega equal to 0. Omega k equal to 0 means omega k equal to 0 means omega equal to 0, and omega square minus 20 equal to 0 means omega square equal to 20 and omega equal to what? Root 20. What is root 20? We will calculate root 20. So it is 4.472 radians per second. So we will take this. Omega equal to 0 does not satisfy because it should be positive, finite, and greater than 0. This omega pc value should be having all these things. It should be positive, finite, and greater. So we will be taking this. So omega equal to omega pc, and that is equal to how much? Root 20. Root 20, that is nothing but 4.472. This is omega pc. Means omega pc is existing, means the intersection point I have to calculate. Substitute this value of omega pc in the real part. This is the real part, so that I will get the intersection point q. So whenever the Nyquist plot intersects the negative real axis, it is nothing but point q. P and q you know, right? So we will calculate point q. Calculate point q. That is intersection point, right? Intersection point. Okay, we will calculate. So real part at omega equal to omega gc. Sorry, pc. So what is the real part? Real part is this one. So let me write that real part minus 12 omega square k, sorry, omega square k divided by omega square into 4 plus omega square into 100 plus omega square at omega equal to what? Omega pc, that is equal to how much? Root 20 or 4.47. Then what is omega pc square? Omega pc is root 20. Omega pc square is 20, right? So we'll substitute here. Substitute omega pc square minus 12. Omega pc square is 20, right? So into 20, right? I hope you are getting omega pc square, right? 20 into k divided by omega square is 20 into, so omega square is 20. 20 plus 4, 24. So omega square is how much? 20. 20 plus 100, 120. So we'll multiply. So how much I will get? Let me simplify it, right? 20 will vanish. So 12 1 ja, 12 2 ja. So what I'll be getting? Minus k by 120 into 2, 240. So this is the intersection point q. So coordinates of q. Coordinate of point q. So here it is, in this problem it is asked to find out the value of k. So we came to know this is the coordinate point. So we will make use of this, and how to calculate I will tell you. Next step 6. Step 5 is over. So step 6. Let me go back to my red color. Step 6. Draw the Nyquist plot. Okay, we'll draw the Nyquist plot. Zero degree, minus 90, minus 180 degree, minus 270. Okay, go to section 1. Section 1, magnitude is, sorry, phase is minus 270, 0 degree, minus 270, 0 degree. Minus 270, 0 degree means point will come here. Next, section 1, minus 90, infinity, minus 90, infinity. You can observe it, minus 90, infinity, I can take it here or here. No problem, you can take it here also, here also. But if you want exactly, go to that point, or else you can take it here, no problem. Is it fine? Or else you have to calculate this point. What is this point? So that you will get exactly, right? Or else directly you can write. But in this problem it will not affect. So minus 90, infinity, I will take here only. Minus 90 and infinity. This is starting point and this is terminating point for section 1. But what is the rotation? You check it. Rotation of plot is 180 degree anti-clockwise direction. 180 degree. Observe here. If I draw it like this, it is 90 degree anti-clockwise, right? But what I want? 180 degree anti-clockwise, right? So observe here. So it will come like this, 90, 90, right? So from starting point, it will intersect the negative real axis and it will come like this. So this is the section 1. Next, come to section 2. This is polar plot of section 1. Come to section 2. Here starting point of this terminating point is starting point of this. Let me take this 90 degree plus 90, it is infinity, plus 90 infinity, plus 90 means here it will come, this is plus 90, 0 degree plus 90, it is infinity, infinity means I have taken here, so I'll take suitable point there. Let me change the ink color, so it's from here to here, from here to here. Let me take this point here, plus infinity, right? So what is the rotation of the plot? This is starting point and this is terminating point. What is the rotation of the plot? It is 180 degree anti-clockwise. So from here to here 90, 90, 180 degree anti-clockwise. So let me draw it like this. Section 2, this is the polar plot for section 2. What about section 3? It is mirror image of section 1. So let me change the ink color. No need to change, but I am changing here. So this is section 1 polar plot. So it should be mirror image, right? So it should be, 1 minute, just you take it like this, right? It should be mirror image. So if it is like this means this has to mirror image, right? I hope you are getting. So arrow mark I'll draw it. What is the intersection point I am getting? Minus k by 240. This is minus k by 240. This point, intersection point. This is q. This is q, and it is minus k by 240. Is it fine? We have found out. This is Nyquist plot. Then come to step 7. So what is asked in this problem? It is not asked to find out what is stability, right? System is stable, but find out the range of k for the stability. So if system is stable means in step 2, what is the stability criteria? N should be 0. N should be 0 means what is the thing? So critical point should lie here, minus 1 plus j0. Minus 1 plus j0, it should be outside. Because n is 0, then only I will get n equal to 0. So Nyquist stability criteria, Nyquist stability criteria, stability criteria from step 2. From step 2, that is what I am getting, n equal to what? How much I am getting? So 0, n equal to 0. What is the meaning of this? Means the Nyquist plot should not, the Nyquist plot should not encircle, the Nyquist plot should not encircle the critical point minus 1 plus j0. So minus 1 plus j0 outside, it is not encircling, right? It is outside. So minus 1 plus, I hope this is sufficient, right? So with this condition, so next, this is O and this is Q, magnitude of OQ from here to here, right? Intersection point, magnitude of OQ is less than what? It is less than 1, minus 1 is here, right? Less than 1 only. If I take magnitude, it is, so magnitude of minus 1 plus j0 is magnitude is 1 only. So it is less than 1. I hope you are getting this length O to Q. Magnitude of OQ is less than, what is this magnitude of OQ? So magnitude O to Q is minus k by 240. It is less than 1. So magnitude of k by 240 means it is plus, it will become plus. So k is less than 240. Right? For the system to be stable, for the system to be stable, the range of values of k, range of values of k are, values of k are, k should lie between less than 240 but greater than 0. I hope you are getting. So this ends here. So I'll stop recording.